And today let's see examples and exercise question of chapter number 7, that is alternating current. Now we are completed till 7.9. Okay, now first let's see example 7.11. Okay, example 7.11, show that in free oscillation of an LC circuit, the sum of energies stored in the capacitor and the inductor is constant in time. Means you have to show that the sum of energy, means energy stored in the form of electric field and energy stored in the form of magnetic field is constant. Okay, so now at any time, if I take at any time t equal to t, the charge in the capacitor q will be equal to q0 cos omega t. This is already derived, right? The charge in the capacitor will be q equal to q0 omega t. Okay, and the current in the inductor, that will be equal to dq by dt. So that will be equal to minus d by dt of q0 cos omega t. So that will be d by dt of q0 cos omega t. So derivative of cos omega t is minus sin omega t. Okay, and q0 d by dt of omega t, it will be omega. So this is the current. So at any time, the charge in the capacitor is q0 cos omega t, and the current in the inductor is q0 omega sin omega t. Okay, now let's find total energy. First we will find out the energy in terms of electric field that is stored in the capacitor. Then in inductor, which in terms of magnetic field. So energy stored in capacitor, the energy stored in the form of electric field, its formula is q square by 2c, right? It's q square upon 2c. So what is q? q0 cos omega t. So 1 by 2c q0 square cos square omega t. Clear? So this is the energy stored in the capacitor in terms of electric field. Now in inductor, okay, the energy stored in inductor, its formula is half Li square. Energy stored in the form of magnetic field, half Li square. What is the current? q0 omega sin omega t. So this will be equal to 1 by 2 L q square, q0 square, omega square, sin square omega t. Now free oscillation, omega is equal to 1 by root LC. Clear? We know that omega is equal to 1 by root LC. Clear for free oscillation? So that will be equal to UB 1 by 2 L q0 square, instead of omega I write 1 by LC sin square omega t. So L gets cancelled. So the energy stored in the form of magnetic field in inductor is equal to 1 by 2c q0 square sin square omega t. So now the total energy U will be equal to UE plus UB. So it's 1 by 2c q0 square cos square omega t plus 1 by 2c q0 square sin square omega t. So this will be equal to 1 by 2c q0 square cos square omega t plus 1 by 2c q0 square sin square omega t. So this will be 1 by 2c q0 square, I can take common, cos square omega t plus sin square omega t. Now we know that cos square theta Okay, and C capacitance, both are constant. So this value is constant. Hence, the total energy in a pure LC oscillation is always constant at any time. Remember, if UE, energy capacitor decreases, the equivalent amount of energy in inductor increases. But the sum of both the energies will always be constant in pure LC oscillation. Okay, this was about example 7.11. Just note it down. Now, let's see some questions from exercise. We already completed the first 5 questions. So let's start with the 6th question. It's 7.6 of exercise. So question number 7.6. Obtain the resonant frequency omega r of a series LCR circuit with L equal to 2 Henry. L is equal to 2 Henry. Capacitance C equal to 32 microfarad into 10 raised to minus 6 farad. And resistance R equal to 10 ohm. Resistance R is equal to 10 ohm. Now there are 2 questions. First, you have to find out the resonant frequency, and second, the Q value. Right? Find the Q value of the circuit. Okay. So for resonant frequency, we know the formula omega 0 is equal to 1 by root LC. So this will be equal to 1 upon square root of L, that is omega, which is 2 Henry. Yes, it's 2 Henry. And capacitance 32 into 10 raised to minus 6. So this will be equal to 1 upon 64 into 10 raised to minus 6. Square root of 64, that is 8. 10 raised to minus 6. So it's square root 10 raised to minus 3. So it's 1 divided by 8. 1 divided by 8, that is equal to 0.125. 0.125 into 10 raised to 3. That implies that the resonant angular frequency, that is 125. Okay, radian per second. This is the value of resonant angular frequency. Now the second question is Q value. You have to find out the Q value. So the Q value, Q will be equal to 1 by R root of L by C. This is the formula for the Q value. 1 by R root L by C. So let's put down the value. Value of resistance is 10. Inductance 2 and capacitance 32 into 10 raised to minus 6. 16. So 1 by 10, square root of 16, 4 into 10 raised to minus 3. So it will be 41 divided by 40. 1 divided by 40, that is 0.025 into 10 raised to, when it goes numerator with plus 3. So the Q value is 25. Okay, the Q value is 25. Clear? So this was about example 7.6. So note it down.